The story of space exploration is a story of giants. Saturn V, the Space Shuttle, and now Vulcan Centaur. Vulcan Centaur, built by United Launch Alliance, is America's next-generation heavy-lift rocket. It's not just another launch vehicle. It's designed to be more powerful, efficient, and versatile than Atlas V and Delta IV. Its mission: secure America's access to space for decades. The rocket stands tall, a symbol of our drive to explore and innovate. Vulcan Centaur is a two-stage vehicle, powered by two B-4 engines burning liquid oxygen and liquefied natural gas, a shift for efficiency and cost. Up to 6 solid rocket boosters can be strapped on for extra muscle. Why another big rocket? Because the world's space needs are growing. More satellites, more missions, more people. Vulcan Centaur is built to meet this demand, carrying everything from military satellites to planetary probes. It ensures the U.S. remains a leader in a crowded, competitive space race. The rocket's design includes reusable engine components, aiming to cut costs and boost competitiveness. Vulcan Centaur is a bridge between the legacy of the past and the possibilities of the future. As it launches, it carries the hopes of scientists, engineers, and explorers. This is the dawn of a new era in American spaceflight. August 12, 2025, Vulcan Centaur's launch for the U.S. Space Force, mission USSF-106, was more than a spectacle. At 8:56 p.m. EDT, engines and 4 solid boosters ignited, lighting up the Florida sky. The mission delivered a next-generation satellite directly into geosynchronous orbit, 22,000 miles above Earth. Achieving this orbit is a marathon, requiring hours of precise engine burns and flawless performance. After the first stage, the Centaur V upper stage took over, executing multiple burns to raise the satellite's orbit. The rocket had to endure space's harsh environment, firing engines at just the right moments. For the Space Force, this was the first national security mission for Vulcan Centaur, a crucial test. The payload, an experimental satellite to safeguard America's space assets. Success would prove Vulcan's readiness for the most demanding missions. The world watched as Vulcan Centaur delivered, signaling a new era for military space operations. This launch was a vote of confidence in ULA's new rocket. The mission's complexity and stakes were immense. Vulcan's flawless performance set a new standard for national security launches. The U.S. Space Force now had a powerful new tool. America's future in space just got a lot more secure. Inside Vulcan's fairing was the Star Navigation Technology Satellite 3, or NTS-3. The first experimental navigation satellite from the U.S. military in nearly 50 years, NTS-3 aims to reinvent GPS for a contested world. It's a testbed for powerful, secure, and adaptable navigation signals, pioneering the future of position, navigation, and timing, PNT. Its phased array antenna can steer multiple beams, focusing strong signals where needed most. NTS-3's software-defined architecture allows updates and new applications from the ground. Unprecedented flexibility. This means it can adapt to new threats or mission needs in real time. The payload was developed by L3 Harris, integrated onto a Northrop Grumman bus, and managed by the Air Force Research Lab. NTS-3 is more than hardware. It's years of research, a bold experiment to keep PNT signals secure for military and civilian life. The satellite is a leap forward in navigation technology. It's designed to keep America's edge in space. NTS-3 is the future of secure, resilient navigation. To appreciate NTS-3, you need to understand the threats it faces: jamming and spoofing. GPS signals are incredibly faint by the time they reach Earth, easy targets for disruption. Jamming floods the signal with noise, drowning out navigation data and causing loss of service. For military units or guided weapons, this can be catastrophic. Spoofing is more insidious, broadcasting fake signals to trick receivers into false positions. Imagine a ship or drone being led astray by counterfeit data. These aren't theoretical threats. They're real and growing, used in conflict zones worldwide. Adversaries deploy jamming and spoofing to gain tactical advantage. The vulnerability of GPS is a critical concern for both military and civilian infrastructure. Power grids, aviation, shipping, and banking all rely on GPS timing. The need for a more resilient system is urgent. NTS-3 was built to answer this challenge. It's designed to keep navigation signals secure, even in hostile environments. The future of navigation depends on defeating these threats. ENTS-3 is engineered to outsmart jamming and spoofing. Its phased array antenna delivers powerful focused beams, signals hundreds of times stronger than standard GPS. High-power spot beams make jamming far more difficult. The antenna can also null out jammers, electronically ignoring interference from specific directions. Against spoofing, NTS-3 uses complex encrypted signals that can rapidly change, making counterfeiting nearly impossible. Its software-defined nature allows it to update encryption and signal structure on the fly. This digital agility keeps adversaries guessing. The combination of strong beams, nulling, and agile encryption creates a layered defense. NTS-3 is a real-world testbed, letting the Space Force refine these techniques for future GPS satellites. The lessons learned will shape the next generation of secure navigation. NTS-3 is building the shield before the battle escalates. It's a proactive leap in satellite security. The future of GPS will be stronger because of NTS-3. Vulcan Centaur's journey wasn't easy. Developing a new heavy-lift rocket meant overcoming engine delays, structural failures, and countless tests. Each setback was a lesson, making the rocket stronger and more reliable. ULA's engineers worked tirelessly, perfecting every component. The successful USSF-106 launch was the result of years of perseverance. Vulcan Centaur earned its place through engineering rigor and relentless pursuit of perfection. Its triumph is a testament to overcoming adversity in the quest for space. Vulcan Centaur's first flight, Certification 1, launched in January 2024. The mission proved the rocket's capabilities by sending the Peregrine lunar lander toward the moon. Vulcan performed flawlessly, placing the lander on the correct trajectory. The rocket's success validated years of development and gave ULA confidence for future missions. Unfortunately, the Peregrine lander suffered a propulsion failure after separation, unrelated to the rocket. The lander's loss was heartbreaking, but Vulcan's performance was a triumph. The rocket delivered as promised, earning trust from customers and the U.S. Space Force. Certification 1 proved Vulcan Centaur was ready for complex missions. The data gathered set the stage for national security launches. Vulcan's debut was a milestone for American rocketry. Vulcan's second test flight in October 2024 swapped its planned Dream Chaser payload for a mass simulator. The launch started smoothly, but 39 seconds in, a solid rocket booster erupted in flame. Despite the anomaly, Vulcan's systems compensated, and the mission succeeded. The incident triggered a thorough investigation, tracing the cause to a manufacturing defect in the booster nozzle. ULA and Northrop Grumman fixed the flaw, improving quality control. The episode highlighted the importance of rigorous inspection and resilience in rocket design. Vulcan's ability to complete the mission despite adversity was impressive. The lessons learned made the rocket safer for future launches. This test underscored the value of testing and adaptation. Vulcan emerged stronger, ready for critical missions like USSF-106. Vulcan Centaur's successful launch of NTS-3 marks a new era, defined by resilience, adaptability, and security. NTS-3's technologies will impact military and civilian sectors for decades. Jam-resistant, spoof-proof navigation means greater security for both soldiers and civilians. GPS underpins global commerce, agriculture, banking, and power grids, all now more secure. Vulcan Centaur is now America's premier heavy-lift rocket for critical payloads. Its reliability ensures sovereign access to space for national security. As space becomes more contested, this partnership of Vulcan and NTS-3 is vital. Innovation and foresight are launching us into a new era of secure navigation. This mission is more than a launch. It's a leap forward for our way of life. The future of space and the security it brings is here.